The best part about coding is the problem solving. That's what makes it fun. It's like it's a game. It's as if you're in a video game and your character is on one side of the screen and you're trying to get him over to the other side, but there's a bunch of obstacles in the way. So you have to figure out what's in your inventory and what can you use, what can you find in the environment that will let you get past those obstacles and over to the other side where your application or your feature or your bug fix is finally completed and done. So let me show you a real step-by-step example of how I build something from scratch and how I break it down into a bunch of smaller pieces that will get me from zero all the way to a completed product. Since I'm comparing the process to a game, let's actually build a game. In this case, Minesweeper. The goal in Minesweeper is to reveal tiles that potentially have a mine behind them, but not actually click on any of the mines. And the way you solve this is any tile you click that doesn't have a mine will tell you how many neighboring tiles in up, down, left, right, or diagonal have a mine next to it. So for instance, if there's number 3, that means there are 3 neighboring mines. So let's go ahead and start coding this and see how we'd build it out. You can follow along with my exact code if you want to. The link in the description has the GitHub repository where this code is stored. And inside the repository, I actually have a branch for every step I'm going to show you here. So you can see step by step how I built up this code as I wrote it. So I'm going to start out by first just having the bare bones HTML with nothing in it, just an HTML shell. So you can see here, all we have right now is the title, Minesweeper, and nothing else. There's additionally a little bit of CSS that helps define some of the stuff in the body. So we have nothing but a blank screen and that one line of text. So the next step is we want to build the basic HTML that will store the number of mines, the counter, the status, and put a placeholder for where we're going to put the actual game board, the tiles. So at this point, you can see we've added some additional HTML here. We've added a difficulty select. We've added the game board here. This stats part will be the top row, and then the board will go here, but we haven't actually done anything with the board yet. We want to generate this in JavaScript. This way, when we go and do the difficulty select, we'll be able to increase or decrease the game board size dynamically. So far, we still have no JavaScript. All we've done at this point is we've added some additional HTML and nothing else. So the next step is we want to actually add the game board. This is where we're going to add our first JavaScript. And you'll see in here, the game is initialized in this init game function. There's going to be 2 possibilities here we can call. If the game board hasn't been initialized yet with the correct size, with the current size we want, then we're actually going to build everything out in the HTML. Otherwise, we're going to just reset the existing board. If you look at the resetting, all we're doing is going over all the rows and the columns and then just resetting the attribute to hidden. And hidden is just telling our code later on that this particular tile has not been revealed yet. But if you look at the actual way we're generating the game board, first, we are clearing out the HTML that's already there in case we're changing from a different size board to another. Then we're actually going to iterate over the number of rows and then actually create the row that'll be an element that gets added to the HTML of the page. And then within that row, we're going to build out all the columns as well, the cells that we're going to add to the row that are also HTML elements. And for each cell and row, we're going to add data points to the HTML directly. So we're going to have the row ID, the cell ID, and then the state of the tile, which is going to be hidden to start with. So once we add the JavaScript and refresh the page, now we can see that we have the game board. It's 9 tiles by 9 tiles. And you can also see that the CSS allows us to hover over any tile, and it's going to have to press the tile so you can tell where you're clicking. So the next thing we need to do is actually make them clickable, because right now when I click on these tiles, nothing happens. And that's because we've told it to do nothing, or I should say we haven't told it to do anything. So now let's actually add in some code that will handle a click when we click on a single tile. So adding a click handler to HTML is pretty simple. You add an event listener to the element you want to listen on, tell it what type it is, in our case, click, because that's what's recognized by the browser as a left click. And then we give it a function to call when that is clicked. And then we define the function up here with it accepts an event. And in that event, you can actually have a reference directly to the element that you've clicked. And then all we're going to do is if it's we're going to check its attribute of the state. If it's already visible, we're not going to do anything. But if it's not visible, then we're going to mark it as visible. So you can see now when we refresh the page again and we start clicking, anytime we click an element here, it's going to stay clicked but there's nothing to reveal yet. So the next thing you want to do is actually generate what's underneath these tiles. Where are the mines, and what are the neighbor counts for any of the tiles that are neighboring mines? So in order to track the tile information, what I'm going to do here is create a board variable that is going to end up being an array of arrays. And it'll be, rows and then columns. And as it says here in the comments, every cell representation here is going to have the number of neighboring mines, 0 through 8, or -1 if there actually is a mine there. This way, we only really need to store the data in one single spot for whether it has a mine or how many neighbors it has. 0 meaning zero mines nearby, 8 being it's completely surrounded, and then -1 meaning it actually has a mine on that. And you see down here, we add a new function called lay mines, and that's going to be called at the initialization of the board, and it's actually going to calculate where the mines are. In our case, we're going to initialize with 10 new mines for this board. So it's going to loop through to try to figure out where to place those 10 mines. And it's going to keep generating a random row and cell, double check that that particular cell doesn't already have a mine. And if it doesn't have a mine, it'll place it there. And then for here, it'll loop through the 8 neighbors, 9 actually. It'll make sure it's not modifying the mine itself, but it'll increment the number of neighboring mines on those 8 cells. This way we can update our neighbor counts. We then call that function here in the init game section after we've assigned the total number of mines. And as I said, I added this new num mines here. So this way, when you initialize the game, you say how many rows and columns, so how big is the game board, and then how many mines are inside that game board. So when we go back to here now and refresh the game, now when we start clicking, nothing has changed because all we've done is created the data that represents the mines, but we're not actually showing it when we click this. So that'll be the next thing I do is actually when we click on a cell, it's going to show us whether it has a mine or if it has how many neighbors it has. And that change will take place inside of the click handler we created earlier. As you can see, before, all we did was mark it as visible. Well, now what we're going to be doing is we're actually going to go through and set it as visible. Then we're also going to check to see what is the contents of that specific tile in the board data I created earlier. So from the element that we clicked, we're going to go ahead and pull out the row ID and the cell ID. And what we'll do then is we'll figure out, okay, does that particular board have a mine? If so, we're going to show a new an image, an explosion image. I added that up here as just an SVG. If the tile's value is 0 in our data, that means there's no neighbors. So I'm just going to do nothing and leave it as blank. However, if that particular tile has a number in there, a positive number, then that means there are neighbors. And I'm going to set the contents of that tile to that number. This way it shows the user how many neighboring mines are in that tile. So again, we go over here and we refresh the page and we start clicking and you'll see all the different values that are underneath. And you can see some are 0, meaning there's nothing there, or it shows blank. We can see where the mines are. We can see how many neighbors each one has. So far, so good. So what's next? Well, now we want to, if you click on a mine, we want the game to be over. We don't want you to be able to keep on clicking things. So let's go ahead and do that one next. The first thing we're going to do is we're going to track a couple new variables. Number one, game running means that we're not in like a win or a loss state, and we can actually click tiles. And lose is another variable that tracks whether or not the user has lost. And those will be set when the game initializes to these values of false. And so we'll do that down here. Lose is false and game running is true when you initialize the game. Then inside of our click handler, we're going to do a few things now. Number one, if the game is not running, so here, then we want to do nothing at all when a user clicks. So at that point, nothing's going to change to visible. None of the tiles will be revealed. If the game is not running, don't do anything. You don't actually want to reveal anything. Second, we want to actually detect when we click on a mine, and that's we already do that here, but now we're going to actually add in lose equals true, so we set the lose state. Game running is false, and we're also going to add a class list to the overall game board of lose. This way, any other future state we add to the game will be able to key off of that to show different colors or different styles on the board. So go back here and refresh the page again, and now we can click around until we actually hit a mine. And now you'll see you can't actually click anymore. None of them get revealed anyway. We can click all we want to, but nothing gets revealed. One other feature of Minesweeper is the ability to mark tiles that you think are hiding bombs. And we haven't done that yet, so that's gonna be the next feature we're gonna add. So the way we're gonna do that is you're gonna be able to right click on a tile and that will mark the tile as what you think is a bomb, or potentially just as a questionable one where you're not sure about. So just like we added a click handler before, we're going to add another event handler to the tiles that'll handle right clicks. In this case, the event that is recognized by the browser for right click is called context menu. So here in where we assign the click handler, we're going to add another handler as well called context menu. And that one's going to be called our right click handler function. So when we go up to that, we're going to do the same logic we did before in the click handler, looking to make sure the game is actually running before we start changing any flags. And then we also want to make sure that the field is not visible. If it is visible, you can't flag it. So that's, again, nothing's going to happen if that particular field was already exposed. But if it's not exposed, then we're going to go through this simple if statement here that allows us to toggle between the three states of mine, meaning you're marking it as it has a mine, question, meaning it doesn't, you think it's questionable, there might be a mine, or just blank, having no data flagged attribute at all. And as you can see, we're marking a flag using an exclamation point. We're marking a questionable with a question mark, and obviously no flag is just blank. So if you look at those changes, we can see now that we can easily cycle through the three states, and it doesn't work if you click on an already exposed tile. So the next thing I want to do is this number up here in the upper left. That's actually supposed to show how many mines are left on the board that you haven't marked. So every time you mark one of these as an exclamation point, this number should go down from the total number of mines that were laid at the beginning. In our case, we did 10 mines. So if we have 5 exclamation points, this number should show 5. So we're going to track the number of cells that are marked as flagged here with a new variable called cells flagged. It's going to be a counter. We're going to update that value here in the right click handler. So whenever we mark a item as flagged, we're going to increment it. Whenever we change it from flagged to questionable, we're going to decrement it. So we have one less marked as flagged. And we want to be able to show the number of remaining mines, so total mines minus the flagged mines, in this here. And that's going to be done by using this update mine count display. And all that's doing here is it's getting the counter. So it's getting this it's getting the element of the counter in the HTML, and then it's setting the text to the actual value of the number. So you can see when we pull up the latest changes, there are 10 mines here. And as we flag things, we're going to bring this down. Now, this is, since the number of mines marked, the game isn't telling you whether or not you're correct or not. You can overclick these, which makes sense. And it's going to show to the user that you've clicked 5 too many. So this is actually working as intended. So the next thing we want to do is have the game win condition. And the way you detect that is you know how many total tiles there are, you know how many mines there are. The way you win is you clear all the tiles that aren't mines. So in our case, we have 81 total tiles, 9 times 9, 10 mines. So if you've cleared 71 tiles, 81 minus 10, if you cleared 71 tiles, that's how you win. So that's what we're going to add next in our code. So we're going to track how many cells were revealed in a new variable. Every time we expose a tile, we're going to increase that number. So that's here and here. And then we're going to check here in the click handler after we've exposed something, if the win condition is met. So in other words, the revealed equals the number of tiles minus the total number of mines. Then we're going to set this new variable win equals true. That's also up at the top here. That's under lose. So we got these two here. We're going to set win equals true. And we're going to mark the board as a win, and we're going to update the status icon. The status icon is the middle part of that top row. I'll show you that in a second. But that update status icon will Basically, I added 3 new images to there, and only one's going to show at a time. A neutral face while you're playing, a sad face if you lost, and a happy face if you win. So we're going to update that icon to display whether or not you've won the game or not. So in this case, if you've lost, it's going to show sad. If you win, it's going to show happy. Otherwise, we're playing the game right now, so we're at a neutral face. So you can see right here we're in neutral. And if we start clicking through, we just lost. So now it's a sad face. So now instead of reloading the page every time we want to play the game, I want to be able to click this icon and have it reset the board. So to do that, we're going to go back to our code. We're going to add a new click handler here to the status icon. This is a status icon here. If you look at our, HTML, up here we have the status icon. Right here, status icon. So we're grabbing that and we're adding the click handler and we're doing a init game on that as well. And then inside the init game, you can see we're resetting the flagged, revealed, win, loss, everything here is reset. So now when we go back here and look at it, when we run into a lose condition, I can just click on that icon and reset the game without having to reload the page. This way it's a better experience for the user because obviously they're not going to know what to do if we just left it like this and you had to refresh the page. They wouldn't know that. I'm not going to go through and actually get to the win condition. If you want, you can do that yourself. I did test it. I made sure it all works, but that would be a very boring part of the video, just watching me click through and probably screw up a few times. So the next thing we're going to do is we're going to do the last part of the status row. And I actually want to be able to show how much time has elapsed since you started the game. So you can see how many seconds it takes you to complete the game and try to beat your own score, basically. So to do that, we're going to add one more global variable, and it's called timer, and that's going to track the timer once it gets started. By default, it's undefined because there is no timer running, but once a user has clicked, I'm going to show you this here. Once a user has clicked for the first time, it's going to check to see if there is no timer, go ahead and start the timer. So up here, we're going to go to start timer. So we're tracking the start time, and then we're starting an interval in JavaScript, which simply means this is going to run periodically every second in our case, and it's going to run the same function over and over again. In this case, every second here, and every second here. And what it's going to do every second, it's going to take that element from the HTML where it shows how many seconds have elapsed, and it's going to update it to the current time, the number of seconds since you started running. And we're going to calculate that by just grabbing the current time in seconds and subtracting out the start time. Additionally, we need a way to stop the timer. This way, when you win or lose or reset it, the timer gets stopped. And the way we're going to do that is here with the stop game timer. So it's going to check to make sure a timer is running. If it is running, we're going to use the clear interval JavaScript function to stop the timer. And then we're going to set the timer to undefined just so we reset our variable back to the initial state. Inside of our init game, we're going to do one other thing as well, and that is we want to set the game time to 0 whenever we reset the game, because the stop timer doesn't actually clear that value. It just stops it so you see how long it took you to win or lose. So now when we run the game, you can see that the timer has started going up every second. And then eventually we're going to win or lose. We'll lose here, and we lost in 9 seconds. Okay, so now for what I think is the most challenging and what was most interesting part of the implementation, and that is when you click on one of these empty spaces, instead of having to then click on all the nearby empty spaces, most versions of Minesweeper actually automatically expand to include all of the connected empty spaces, including those that have neighboring mines. So you're just going to include these 2s, these 1s, these empty spaces here, and it's going to keep going out until it runs into all of the different ones that actually have neighboring mines. So in order to do that, let's go back to the code. That's obviously going to be done in the click handler. When we detect that we've clicked on a tile that has no neighbors, we want to now change the behavior from just revealing the tile to recursively looking through and finding all connected tiles that we should be showing as well. So here, before it was just setting it to visible, but now I've set it to this new function called reveal connected empty spaces. And if we go and look at that, So we're going to be calling this function recursively. So I want to have some basic sanity checks. I want to make sure that the row and the cells are both valid numbers, meaning they're greater than or equal to 0, and also not exceeding the size of the rows or the columns. So that's what this line is doing here. And if it is, it's just doing nothing. And I'm doing that this way I can avoid that logic further down in the same function. But then what we're going to do is we're going to grab the cell and figure out what number one, is it visible? If it is visible, then there's nothing to do. We've already processed this particular cell and we can move on to another one. If it's not visible, then we're going to set it to visible and update our revealed count. And then now we're going to check to see, number one, is it totally empty? If it's totally empty, we need to repeat this whole entire process for all neighboring cells. So we're going to, that's down here. So that's where the number of the value inside the board is 0. So now we want to recurse. So what we're going to do is we're going to, for all of the neighbors, we want to call this reveal connected empty spaces and basically try to expand out the view of those tiles. But if the tile does have a number of neighboring mines, then we want to still show it, but we're not going to actually recurse anymore. We've hit a dead end and we can now stop recursing for that particular direction. So with this new code, we go back to our code again. And now we can see, let's see if we can actually find one that has, there we go, empty space. It opened up everything connected to it. Let's see if we can get, oh, that was a big one. So now you can see that it's working pretty well. All right, so next what I want to do is, if you notice, when I lost here, it'll be nice to be able to see where all the bombs are once we lost. So let's go ahead and add that in and figure out a way to show the bombs that have lost. Additionally, it would be nice to know if these flags we put down, whether they were right or not. So that's going to be in there as well. Okay, so back in the code, we're going to go over to the click handler. And in the case here where we've lost, I'm going to add a new function called reveal mines. And that will do as you expect. It'll reveal what are mines, or the location of the mines. And that is going to be pretty simple. We're just going to loop over the rows and the columns and check our board to see if a mine exists there. If it does exist, then what we're going to do is, number one, if it exists and the tile is not visible, then that means that that wasn't the mine that we exploded. And in that case, we're going to place down a bomb SVG image, which I also added to the code up here. So another SVG here. But we're going to add that to the cell. And then we're going to mark it as visible so it shows on the game board. Additionally, our CSS is going to be modified so that when, let's see here, if the game board is in a lost state and the cell is marked as a mine, then it's going to be marked with red. So you're going to see that it's marked incorrectly. If it was marked correctly, meaning it was flagged and we put a bomb there, then it'll be marked, the bomb will be green. So let's go ahead and see what this looks like. So, whoops, that was fast. So if you'd see, exploded, and we have black bombs everywhere we did not correctly flag the bombs. So now let's go ahead and reset this. Let's see if I can actually find one that, or mark stuff. All right, there we go. That works. Mark that, and then let's mark some ones that are wrong, and then let's blow ourselves up. Okay, so now you can see that these exclamation points that we marked are wrong. So now they're marked in red. These bombs we had marked correctly, so they're green, and these black ones we didn't find, so they're black. And we exploded this bomb, so that's where we're at. So at this point, the game is basically working. So the last thing we want to do is be able to change the difficulty. You can see here I have this easy, hard, and expert, but it does nothing right now. And all we really want this to do is just change how big is the game board and how many mines are we putting through the board itself. So to do that's pretty easy the way we structured our game before. We go back to our code and we go back over to where we initialize the game. Now what I'm going to do is I'm going to have this new function called init game for difficulty, and that's just going to add some additional classes to the game board when it gets initialized. This way we'll know how wide the CSS needs to be, how wide the actual, how many pixels wide we should have it. So I'm defining that the easy is going to be 9 tiles wide and high. The hard, hard is going to be 16 and expert will be 22. So we're going to add the appropriate class to the game board, and we're going to initialize it with the values for the size. And we're also going to change the number of mines, 10 for easy, 40 for hard, and 99 for expert. Then we're just going to grab that select out of the HTML, add a listener, in this case, a new one you haven't seen before, which is change. Whenever that value changes from the select, then this will get called. And whenever that happens, we're going to reinitialize the game and completely change it all. And if you remember, we had this logic over up here in the size, in the init game, where if the size is different, we're going to just reset the board. If the size is the same, we're going to reset the board, but if it's different, we'll reinitialize. So now we'll actually see this in use. So now when we pull up the game, we can see that this works normal, but if we change the difficulty, now we actually have a hard, which is, medium size. Let's actually blow it up. You can see a lot more mines. And we go to expert and we have a much bigger one with a lot more mines. So that's it. Nice and easy. So you can see when you break down the problem, it makes it a lot easier to get from absolutely nothing to a completely finished product. And you don't have to have a plan before you start. I just decided, okay, I'm going to make this Minesweeper clone and started from absolute scratch, but that was about it. It's all I had from my plan. I just dove in and started adding pieces that got me closer to where I wanted to be. And that's really the key is, as long as each step you make gets you closer to the goal, then you're on the right track. Maybe you do make some mistakes here or there, but as long as you keep course correcting after each step, that's the best way to break this down into small problems. And often the closer you get to your goal, the more obvious the next steps become. So, when you're far away from your goal, there's a lot of different things that are missing. So there's a lot to choose from. And then when you get closer to the goal, you realize, oh, there's only this last little bit of a gap that I need to close. So I personally like problem solving this way and creating applications this way. But sometimes it does make sense to plan things out. But in general, I prefer just kind of dive in and just start troubleshooting on the fly. Well, like I said, if you want to check out this code, check out the individual branches that show the different steps. The GitHub is in the link, totally free. Just go ahead and grab it. Hope you enjoyed this video. Thanks for watching and hope to see you next time.